Thank you for that, Israela. Let us now proceed to vertical asymptotes of a rational function. Vertical asymptotes of a rational function. We know that a rational function is of the form r of x equals f of x over g of x, where f of x and g of x are both polynomial functions. A vertical asymptotes occur when the denominator of a rational function approaches to zero. Another is that a vertical asymptote of a function is a vertical line that the function approaches but never touches. In the case of a rational function, if the denominator of a function is zero at a certain x value, then the function goes to positive, negative, infinity at the x value. And there is a vertical asymptote at the x value. An example of a vertical asymptotes of a rational function is f of x equals x plus 2 over x squared quantity x plus 4. This function shows that x is equal to negative 4 and x equals 0, which are the vertical asymptotes for the graph of f. Since the denominator contains the factor x minus negative 4 and x minus 0 squared, we expect the graph of f near the line x equals negative 4 to resemble the figure 1 for its reflection in the x-axis, and the graph near x equals 0 to resemble figure 2 for its reflection in the x-axis. For x close to 0 from either side of 0, it is easily seen that f of x is greater than 0. But for x close to negative 4, saying that x equals negative 4.1 and x equals negative 3.9, we will have function of x greater than 0 and function of x less than 0, respectively. Using the additional information that we have, in which there is only a single x-intercept of negative 2 and 0, we obtain the graph of f that is shown in figure 3. As you can see, these equations are also the examples of vertical asymptotes, because when we try to solve for its limit or by substituting, we can see that the denominator will get a value of 0. One-sided limit. Let us now proceed to one-sided limit. An example of this is a function of x equals x over square root of x plus 2. By inspection of f, it reveals that its domain is the interval negative 2 and infinity, and the y-intercept is 0 and 0. Let's try to look at this table. We can see that the value of f of x decreases without bound as x approaches to negative 2 from the right. Hence, the line x equals negative 2 is a vertical asymptote for this function.